You should be able to see my PowerPoint thing right now. You see?
Yeah, looks good.
I just wanted to take you over a little bit about the micro SD card functionality in the FRDM K64. This could be a possible idea for a final project or something that anybody wanted to work on in the class. And to give you a short example, and then I'm going to move on to just a few things about the board that might be of interest to students. So the SD card functionality on the FRDM K64 is handled through an SPI interface on the board, and that is it takes place through these pins here, which are circled here. So when you're setting up the SD card functionality in your embed online compiler and IDE, you're going to have to set up your SD cards to use these physical interfaces, and you're going to have to use that to read and write from the card. So what you have here is the master out slave in, which is PT3, and master in slave out, PT1, serial clock, and chip select, which you probably are already aware of from your microcontroller class. So what is a file system? A file system is used to organize essentially raw data transfers to and from a device, so that you can create a structure that has things like permissions, metadata, memory allocation, essentially a system for organizing file read and write to a system. If we had to write individually to each block, it would get pretty difficult quickly. So file systems allow us to have an interface which we can use to handle files in an abstract sense of, we're not worrying about what sectors we're writing to. If we're writing to two sectors at the same time, or different things like that are held behind a silk screen for that file system. An example of a file system would be like FAT32, NTFS, Max HFS plus. You have these on the computer, all sorts of devices. They sort of handle file access and for storage devices. So the syntax for using the SD card in embed, they have a class called SD file system, which you can find on the web by just searching SD file system embed. And if you are going to use this class, I suggest using the right embed version. The embed library has had many different versions over the course of time, and with different user-created libraries. Some of them aren't compatible with newer versions, and some of them aren't compatible with older versions. So whenever you're going to actually use these devices with user libraries, you're going to have to kind of mix and match and find the right embed library that will work with your user library, and possibly modify things to fit. But this one seems to work quite well with the embed versions that we use in class, which is why I suggested it. It starts by just declaring an SD object that takes the parameters of the device SPI device hardware ports that you're using for the SD interface, which are the master route slave in, master in slave out, serial clock, and chip select that we just went over. And the fourth parameter is the name for the storage device. So if you wanted to create a volume called, a student or something, and then you want to store files on it, you would call it student instead of SD. So if you're familiar with PRG 255, you will know that you can use the different fread, fopen, fclose, file type, directory type, dir type, all these sort of standard C file manipulation tools to manipulate objects in your hard drive. So you can use the same ones for this SD file system library. So once you've imported the library using include SD file system.h and imported the library and everything's working, you can manipulate the files on the disk by just using regular C functions for doing this switcher. You can use mkdir to create directories and delete them. That's what we do. Here's a quick example which shows the SD file system library in use. You can see that at the beginning I just declared the SD object, the SD file system object, and after that just created a buffer which is used for file access, the same what you would do in PRG 255. And I created a directory called mydir, and the second parameter of that is 0777 is the file permissions, which are set to everybody. Basically, anybody can access the file instead of just certain users. The dir is just opening the directory list, and there's a while loop underneath where it's reading the directory names from that directory that I've opened. So essentially, same kind of structure that you see in PRG 255. But it's kind of neat because now you have the ability to create files and store sensor data from files, and they can be recalled later. So if you wanted to say use the device to record some sensor data outside of your computer instead of being kind of hooked into a USB, you could run it off a battery or something and record your sensor data and then recall it off your computer, and you have kind of like a sensor, for instance, a temperature sensor that you could keep in the yard or something like that. Or what I've done here is just a really simple example of using the accelerometer on the device to create some data for motion, for instance, like motion. If you were to like drop the unit or something, you could measure the acceleration of gravity or what have you. So I created this kind of quick example which I was really working on. One second. Right, so you can see my COM screen, and this is my FRDM K64 plugged in. I've got one button here that just sort of resets the file, so it just deletes it and recreates the file. So I'll press that, and it says files have been deleted and recreated. And I've got another button that starts the capturing process, and the light will now go green. It should go green. So it's starting. So now when I move this around, hit the button again to stop it, and it should print out the data of the G-forces measurement of the accelerometer, which is essentially how it works at code is that it has kind of like it's a small device that can measure the resistance of springs inside it against some kind of like cluster sensor or something like that. And it can tell you what the acceleration of that chip is based on how much it's moving and the resistance of the springs inside, or something similar setup. So if I wanted to, I could take this information, which is just acceleration, and I could convert it into speed. I could convert it into position. I could tell if I drop this thing off a building or something. I could use the acceleration data. I have to convert it obviously because acceleration has its position, but you could convert it using the fact that acceleration is just a change in velocity, velocity is a change in position. So you could set your starting point at 0 and measure your speed or your position as the object's falling or something, and it should match. If this accelerometer is accurate, it should match whatever position it is pretty much. So like, you should be able to see the trajectory of the object. So there's just a quick idea. The code for this is just using a library that I found seemed to work, called which is named after the device. So we'll bring it up. So if you can see my screen here, it has the code. You know, this library here, the FXOS8700Q, is the name of the device that is the accelerometer. It's the name of the accelerometer, and the accelerometer, as you can see in this image, or sorry, not this image, but okay, I don't have the image, but it works over the I2C interface. You can see here SCL, SVA here at the top for PTE 24 and 25. These are the interfaces for the FXO. So, you know, the accelerometer, it's fairly straightforward. You create an accelerometer object, and you feed it the I2C object from embed, and it takes 2 parameters here. Once you've created it, you can create floats and use the .get x, get y, get z to get the data from the accelerometer, and that's essentially all I've done here. That's just essentially getting that data and presenting it in file using the SD file system. And so that's just a quick example. You know, you wouldn't be able to actually use this code in class, for instance, but you could go along the same lines and do something else. Personally, I found using the accelerometer library and the SD file system library is a bit finicky with embed. In terms of its versioning, I had some issues with using battery power, for instance. Some of the older libraries don't seem to take well to that, and whereas the newer ones seem to allow for battery operation or external power to be used. I found that some embedded OS versions seem to have trouble with that. And those tend to be the older versions that might work with these libraries. But anyway, you can mix and match them. Use different library to do the same thing. It's essentially just an example. So yeah, just a word on advice on that one. Make sure that whatever project you do choose to do with the FRDM K64, if you're going to use the embed like the way that we did in the past, that you should make sure that the libraries work first together, and then and also make sure that the hardware works first before you write your code. That being said, that's pretty much my presentation on what you can do with it, for sort of ideas and that kind of thing. For those having issues with the unit, the setup for this unit is fairly, it has a few gotchas, so I just thought I'd go over quickly some of those and make sure that just for those having issues to make sure that they can get on track or what have you. If you pull down the reset button on the K64 as you plug in the USB interface, it will go into maintenance mode or bootloader mode, where you can drag and drop files onto the unit in order to do things like updates or changing versions and that kind of thing. The DAP link firmware that's used on this unit is you have to install a version of that. Sometimes upgrading that version can fix issues that are having with the unit. So if you are having any issues with it, that you kind of reach the point where you're not sure what to do, one thing you can do is reload a few items, a few files onto the system, so you can write some data onto the system, replacing the bootloader, updating the bootloader, I should say, and updating the DAP link for the firmware, which are just quick, simple things that you can do. Essentially, you just put it into maintenance mode by holding down the reset button and plugging it out and plugging it in, and it should start blinking the light on the unit. You can go to this website. You see my, yeah, you can see, just lost track of it after right now, but so this website here, it has some information about updating the bootloader. You can just Google document bootloader update or something like that, and it should come up. This has some step-by-step instructions that I found helpful sometimes when I was having issues with it. You can download this file here, bootloader update, put your device into bootloader mode, and drag and drop the file onto this file onto the DAP link, or say bootloader instead of DAP link. And that should update the bootloader. Before you do this, you're supposed to disable this part of this Windows feature called storage services here, which has instructions on how to do. You just type, you just type Command R, Windows R to bring up the run menu. Type in services.msc, as it shows here. And you just go down the list of storage services and stop this service for a minute while you're updating the bootloader, and then you restart it afterwards. The other thing you can try is, once you're done that, you'll need to add the DAP link software back up again. You have to set up the drivers for that again. So you have to download, you can just sort of search for FRDM K64. Then see if that comes up. All right, so at the bottom here. Just scroll all the way down and right here, the that link firmware update. So you'll need to go to this link, download this link file and this firmware file, and drag it onto your system. If that fails and you're really struggling, there's also sort of little kind of jumpstart thing that you can do with 2 of these units, where if you're really stuck and your system's just not being friendly with your Windows machine or your Mac machine, you can get someone. You can bring it into a class, and possibly maybe a professor or somebody from the IEEE perhaps who has one of these boards, including myself, can help you by jump starting your FRDM K64, and that just entails taking this sort of SDA out of the board and putting it into your board and starting it up, kind of like you would start the car or something like that. So you can do that if you're not. There's a process for how to do that on the same page here that I told you about, the Bootloader update page, I believe. Down here right here, it says, if you've determined that your board is in a brick state, we publish a second blog with instructions on how to recover the bootloader. So if your bootloader is having issues, like you can't get that link to show up and there's nothing showing up, there is a way that you can use Python and a few similar things, but this would be just bringing the board in and having somebody who has a board that's working with the school helping to get yours up and running. That just sort of a procedure like this. As you can see here, there's 2 boards here, and you have to download Python. I think that's pretty much it. So, and that's pretty much what I had to go over today. So, any questions about that? Is anybody still here?
Still here, don't worry. That was great. Thank you, John. It's a really nice overview.
Yeah, so it's a good board to work with. I heard that some students are having issues with embed and versions behind that, and that was like my #1 source of issues as well. So most of the time, almost like 80% of the time, I found that it was just the version of embed that I was using a certain feature that was causing conflict or something like that. So the actual hardware of the unit is pretty solid, but it's kind of open for users to come in and make their own libraries with it. And I think sometimes there's some context with how the networks with those libraries and they don't work anymore. So almost every single library that you come across, you're going to have to do some troubleshooting.